This is the makeup for turn up the volume, in particular section 4 or part 4, where we have to figure out the volume of an irregular shaped object such as a rubber stopper, and it's going to continue on till the end of the handout. So part 5, 6, and the blue cube at the bottom. So what I'm going to talk about real quick is part 4. What you're going to do is you're going to get a rubber stopper and you're going to try to figure out the volume. And what you're going to see in the video is I'm going to solve these problems for you now because you were absent. The big part of this lab was trying to problem solve how to figure them out. So you're going to miss that aspect of it. But you can describe what I do and then draw a picture to illustrate what happens. And then there's similar things for all the rest of them. So use your handout. I probably won't show the handouts again, so make sure you're kind of following along in the video with the handout. So we're going to figure out the volume of a rubber stopper, which is an irregular shaped object. I'm going to pour some water in a graduated cylinder, and I got 30, 35, 38, 39 milliliters of water. I'm going to drop in a rubber stopper, and it displaces or moves the water up from 39 up to 40, 41, 42, 43, 44, 45 milliliters. So it displaced 6 milliliters of water, so you know that rubber stopper has a volume of 6 milliliters, which by the way is the same as 6 centimeters cubed. Milliliters and centimeters cubed are the same thing. So that's how you'd figure out the volume of that. The next thing I ask you to do is figure out the volume of a rock. Here's a rock. Problem is, the rock won't fit in here. So students problem solved and figured out that they could fill up something called a dribble cup. So you just fill that up with water. It's going to dribble out, so I'm just going to catch it with something here. Catch it with this since I already have it. Let it stop dribbling. And then I'm going to get an empty graduated cylinder. Doesn't have any water in it. Put it directly underneath of that. Put the rock in here. It will catch the water, and now the water has been displaced. And we now know that the rock has a volume of we're in between 19.5 and 20, so I'm going to round that up to 20 milliliters. So that rock has a volume of 20 milliliters. And then once you've been asked to do that, I ask you to figure out the volume of a cork. Problem with a cork is that it floats. So students had to problem solve this again. Most of them went for this graduated cylinder, and they filled this up with some water. Going for 70 milliliters there. And the problem with the cork is it floats. So you can't really figure out its volume. You got to get it underneath the water. So what students did, they problem solved. They remembered that this had a volume of 6 milliliters and it sunk to the bottom. So students that were really thinking figured out they could do this. And now the volume went from 70 up to 78 milliliters. So it went from 70 to 78. Remember, this had a volume of 6, so you should now be able to figure out the volume of the cork. So that was another thing that students problem solved. Last thing I asked them to do was to use the blue cube over here and measure its volume the old-fashioned way, which is just length times width times height. And you'll see it has a length of 1.0, has a width of 1.0, has a height of 1.0. Oh, you can't see where I'm blocking that. So I'll just show you one more time here. There, it has a width, length, and height of 1.0. So you can tell that the volume is 1.0 centimeters cubed. So what students did after that, they compared it with this method of displacement, where you have 20 milliliters of water in here. You put this in, and it goes up to 21 milliliters of water, also 1 milliliter. This proves to you that a centimeter cubed and a milliliter are the exact same thing. That should be enough to finish up your handout at home if you were absent for the lab.